Geometry Lesson 4.5, we will be talking about conditions for congruent triangles. In this lesson, we'll only have one theorem. That's Theorem 4.5.1. This is the side-side-side congruence theorem, or SSS. You've already learned three other theorems or postulates for proving triangle congruence. This will be the last one and actually the easiest one. We're going to demonstrate side-side-side by doing a construction. So we take triangle ABC, and what we're going to do is construct each side equivalent to make a new triangle. So draw a line XY, and then you're going to measure AC, and you're going to put your compass point on X and strike an arc about halfway in between X and Y and above the center of the segment XY. Then you'll measure segment BC with your compass, and you use that width. You place the compass point on Y and you slash another arc. Where the two arcs intersect, we label that Z, and we draw segment XZ and YZ to make our triangle. So we've copied three sides equivalent and congruent to triangle ABC. So the side-side-side congruence theorem states if each side of one triangle is congruent to the corresponding side of a second triangle, then the two triangles are congruent. The next slide that I'm going to show you shows the counterexample of side-side-side, which we call SSA. So we begin with the same triangle ABC, and we draw line X. We construct XZ congruent to AC. So you're going to measure AC, keep the width, and you're going to let me reverse that. You're going to copy angle X first. So you'll be copying angle A, and then you'll make that congruent on line X and create angle X. Then you'll construct line XZ, or ray XZ, congruent to AC. After you've done that, you measure CB with your compass. You use that width to make an arc centered at Z and intersecting the other side of angle X. One thing that will happen with this construction is when you're drawing the third side of the triangle, you have two options to draw that will be the same length. So if you measure BC and you put your compass point at Z and you swing an arc, you actually have 2 points that intersect line X. You have point Y1 and point Y2. Having two sides like this, or two options like this, makes this construction not a proof of the theory. So side-side angle will not work. Now I mentioned this in a previous lesson that we will not be using SSA in our high school geometry, and this is one of the reasons why. So these are our conditions for triangle congruence. The four conditions that we can use to prove triangles are side-side-side, side-angle-side, angle-side-angle, and angle-angle-side. The two conditions that you may not use are SSA and AAA. We haven't discussed AAA in your book yet. They go over it briefly, but basically what can happen with comparing three angles of a triangle to three angles of another triangle, as you can actually have the same angle measure, but you can have different side lengths. And for congruency of our triangles, we need to have the same side length. We'll actually use AAA later on when we do similar triangles. So lesson 4.5, your homework, is numbers 1 through 12, number 13, and number 21. In your book, I believe it says to do one of those flow proofs for number 21. Please do a 2-column proof. I've provided a word bank on this slide for both number 13 and number 21 for your proofs. This should be a fairly easy lesson to do. If you need any help, be sure to contact me, and we'll see you soon.